Okay, so 4, 6 is super short. Check it out. It's another graphing uh section. So on these, let's go to the explanation. You need to have I think it's on your formula sheets that I sent you. I think you should need to have that ready, or if not, I'm gonna send you some more details. But basically, have this information at the ready. What is the domain and range of cosine? Cosine can accept any angle, and it's all real numbers. It goes on forever. Notice how there's no gaps, but it does have a high point and a low point for your range. So the range will always be between here and here, hence the -1 to 1. Sine will be the same, it just has a different starting point. So they look very similar. Secant and cosecant, because they're reciprocals of sine and cosine, or cosine and sine, have division by zeros at specific angles. So anything that causes zero in cosine would be undefined in secant. So let me leave that up here. So these zeros right here, notice how they're being related over there. They become asymptotes. Zeros, zeros. So that's why this graph looks that way. And then these zeros are different spots, but you can see they're related to this. Okay. So just know that, okay, the domain is everything except those problem areas that cause the division by zero. And also remember the ideas of functions from college algebra. Domain and range will be flipped. Oh, well, that's for later. Never mind that. That's for inverses. But anyway, ranging, remember that have these notes somewhere, um, what the basic functions look like, the domain and ranges for both. Tangent is a ratio of sine and cosine, so anything that makes I'm sorry, anything that makes cosine zero is going to be another asymptote area. So hence, any odd multiple of pi over 2 will cause problems for tangent. Cotangent is a reciprocal, so anything that causes problems for cotangent will be whenever sine is zero. Hence the different locations for the asymptotes. So as long as you have this information somewhere, you can answer this guy just concepts. It's all conceptual. It's just like, okay, well, what's the domain? What's the domain of this guy and this guy? So that's something that you just either need to memorize or have on a formula card. Okay, nothing crazy. Then number two, from the homework, they have these graphs and they want you to know, okay, which one's which, right? Just match the graphs. This one looks like tangent. Is it shifted? I don't think so. Oops, I meant I hit the wrong button. Asymptotes at the right spot, right? They should be pi over 2, so this guy looks like either secant or cosecant. So what I would do is just graph each of these and then just match them using Desmos, or you can use the pieces here, right? Cosecant has an amplitude of 2. This tangent both have amplitude of 1, so they shouldn't change. And let's look at the explanation. Oops, I left some marks. Yeah, check it out. And here they do it all by hand instead of just graphing it. I don't recommend you do that unless you have to. But they try to find the easy points, like the intercepts, the zeros, and then they match it up to these guys. So if I plug in 0 right? Since it's right at zero for the first one, zero, zero has to be a point. And since it looks like tangent, it has to be plugged into one of these. So plug in zero, zero into both and see, do I get zero? That will kind of help rule out some questions. Then you look at this one. We have a zero at, looks like 3 pi over 2. No, what is that? I can't read that. 3 pi over 4 right here. So plug in numbers and see if you get it. 0, -1 is one that they use for part B. That helped them rule out quite a few questions. So the first one was pretty clear that it was tangent, as I said earlier. And to verify is use the 0, 0. If you plug in 0, 0 into those three that I said, only one of them will be true. Here they use an intercept and they plug it into anything that looks like a tangent type. So again, the first two are the ones they choose, and it turns out to be the cotangent. And then part C, we said it has to be secant or cosecant. So pick a nice point that's easy to test and just plug it into any secant and cosecant problem. So that's how you would do it by hand, but you still need the calculator to get these values and test. So I would just graph them and verify. Graphing them is pretty annoying. I don't suggest doing this by hand. I hate it personally. I'm gonna delete these from any exam, but for the homework, I'm gonna leave them there so you can mess with it and practice. But basically, you identify the asymptotes, identify the easy numbers on the unit circle, or graph the original cosecant, and then shift it by pi over 4. Right, remember what this pi over 4 will do, right? Yeah, it looks like you set this inner part equal to 0 and figure out, let me see, where is it? Cosecant is 1 over sine. Sine has problems, or is 0 at 0 and pi. So you would set the inner part equal to pi and solve. There's one way to do it. To consider the sine, graph the sine, and then see. So it's a lot easier to just graph it. When is it 0? Well, that's where the asymptotes are going to be, like we mentioned before. So they're in there, and then you kind of just sketch it. It's going to be somewhere between the asymptotes. So the only point you need is this guy. To find an easy point using your circle. Like, okay, well, what's an easy one? Well, when sine is 1 would be the easiest, or -1. So go to your unit circle and figure out, okay, how is this inside going to be one of the easy angles? Okay, let's see here. So what I would do is just this. Cosecant of x minus pi over 4. Let's graph it. The easy point is right there. Asymptotes, we already know where they were, right? By looking at the original, by looking at the sine version to check it out. You can see, where is the line function? that right here is my asymptote. Right here is another one. Anywhere that the sign is zero is your asymptote. Asymptote from college algebra meant a point you can't cross. Vertical asymptotes are caused by division by zero. So you can see whenever the sign is zero, we have the asymptotes. I didn't draw all of them. I missed one, I guess, but you get the point. And then the peaks, right, are these values right there. So if you draw the original, you can find these easy peaks and then just put the asymptotes there. But with the graphing calculator, you can get this no problem. Because all you would need for that question, I don't have it, is that point on the peaks and the asymptotes. But to do it, I would just do it on the graphing calculator or Desmos. Not a, again, I'm not going to test you on 4-6 really. Now that I look at it, it's just graphs. I'm going to be minimal on the graphs. But anyway, I'll make sure to send you all the reviews soon. But that's pretty much it for chapter 4. 4-1 through 4-6 would be on test 1. But again, I'm not going to lean too heavy on 4-6 at all. Maybe not at all. Anyway.